time shifting is another important manipulation of signals. Now first we will take a look at one of its uses and come back to discussion of time shifting. In the timeline, we have an audio clip here. Now it is of duration 1 second. When I press the play button, it plays instantaneously. Now what we want is, we want it to play after 1 second. That means we have to move this signal by 1 second. Let's do that first. In order to do that, I will insert a silence of duration 1 second prior to this signal. Let me click OK. Now we can see in the timeline, the signal is shifted right by 1 second. Now let's play it. So it plays after 1 second. So what we have done here is we have delayed the signal by 1 second. Or we can say that we have shifted the signal in time by 1 second. Now let's see time shifting. Now let's say we have this signal which is discrete, that is x of n is 2, 1, 3, 2, 5. The value of x of n at n equal to 0 is 1. Let's say I want to shift this signal to the right by 1 position. That means I need a y of n which is equal to, when the signal is shifted right by 1, the origin should be at 2, 1, 3, 2, 5. Now the question is, what is the relationship between x of n and y of n? Now if you observe these two signals, that is y of n and x of n, we can get y of n by delaying x of n by 1. That is, y of n is equal to x of n minus 1. Now let's quickly verify this. So y of 0 will be equal to, we'll substitute n equal to 0, x of n minus 1, that is minus 1, that is equal to x of minus 1, which is 2. Similarly, y of 1 will be equal to x of n, which is 1 minus 1, that is x of 0. For n you have to substitute 1, and so 1 minus 1 we will get 0. X of 0 is 1. So we will get this signal here. Now let's represent this data in this table, x of n, and let's say here we have y of n. Now x of 0 is 1, x of 1 is 3, 2, 5, and x of minus 1 is 2. Now y of n was the signal shifted to right. So this 2 will come here. So we have 2, here we have 1, here we have 3, here it is 2, and here it is 5. Let's look at how the plot of x of n and y of n will look like. Now here we have x of n, this is x of n, and here we have y of n. We can see y of n is x of n shifted right by 1. Now I have put the reference line, so it will be more clear now. So here y of n is x of n minus 1. So we can see when it was x of n minus 1, the signal shifted right by 1. Now what if I want to shift the signal by 2 positions? It has to be x of n minus 2. Now how that signal will look like? Now let's say we want x of n minus 2. That means the signal will shift right by 2. So x of n minus 2 will look like this. Now what if I want to shift the signal in the other direction? That means so far we have been shifting the signals towards the right, and what if I want to shift the signal towards the left? Now let's see that case. So this is our x of n, similar to a previous example, and we need y of n, which is equal to 2, 1, 3. Y of n for n equal to 0 is 3. That means we have shifted the signal left, 2, 5. Now if we compare these two signals, we can define the relationship between y of n and x of n. That is, y of n equal to x of n plus 1. Let us verify this. That means if we need y of 0, that will be x of 0 plus 1. That means x of 1, which is 3, and y of 1 will be x of 1 plus 1, which is x of 2. X of 2 is 2. Similarly, we may go the other way, that is y of minus 1 equal to x of minus 1 plus 1, which is 0, that is equal to 1. So we can calculate the values of y of n. Now let's see the table. So x of n is 2, 1, 3, 2, 5. Y of n will be, so this will come here, 2, 1, 3, 2 and 5. Now let's see the plot of x of n and y of n. This is our x of n, and y of n will be the signal shifted leftwards by 1. So it will look like this. So this signal is y of n equal to x of n plus 1. Now this signal y of n is x of n shifted to the left by 1. What if we wanted to shift it by 2 positions? So that will be y of n equal to x of n plus 2. So the signal will move left by 2 positions. So this is our original x of n, and it will be shifted left by 2 positions. Now we will discuss about the general case. That is y of n equal to x of n minus n naught. Now it is obvious that in the case of discrete time signals, this n naught must be an integer. For simplicity, let's say n naught is a positive integer. Now under this condition, the y of n, the signal y of n will be x of n shifted right by n naught. Just now we have seen that x of n minus 1 will shift the signal right by 1, n minus 2 shift the signal right by 2, and so on. Now this is not the only case. We have also seen y of n equal to x of n plus n naught. Now here also we consider n naught to be an integer, and if it's positive, it must be an integer, and if n naught is positive, we can say the signal is left shifted by n naught. Now remember, these two are under the assumption that n naught is positive. Now the reason is obvious, because if n naught here is negative, then we will have in effect a left shift. So the points to remember is n naught must be an integer, since we are dealing with discrete time signals, and if n naught is positive, in this case the signal is right shifted by n naught, or we can say, in other words, it will represent a delayed signal. And here left shift means y of n, the signal is advanced. So this is our signal x of t. Now in general, time shifted signal will take the form x of t minus t naught. So let's say this is equal to our y of t. Now if we assume that t naught is positive, remember t naught does not have to be an integer in the case of continuous time signal. So with t naught positive, we have two possible cases. That is, one is of the form x of t minus t naught, and another is x of t plus t naught. Let's say this is equal to y2 of t. Now this x of t minus t naught, it represents a right shift by t naught. This will represent a left shift by t naught. Now let's consider the first case. Let's say t naught equal to 0.5. That means the signal should shift right by 0.5. So the signal will look like this. This is x of t minus 0.5. Now this is x of t minus 1, t minus 1.5, t minus 2, and so on. Now let's consider x of t plus t naught. With t naught being positive, this means the signal will be left shifted by t naught. So let's say here we have our original x of t, and this will be x of t plus 0.5, this will be t plus 1, this will be t plus 2, this will be x of t plus 4, and so on. Here we can see that the signal is shifted by 4 units. Spend some time, work out some of the problems. And in the next video we will see about time scaling.